you can use that single factor, the identity of the laptop, as a stand-in for identifying Mike, and make a completely transparent but highly secure, unphishable authentication flow. So you can raise the security bar and raise the usability bar at the same time.
Welcome to the DevSec for Scale podcast, the show that makes security a first-class citizen for growing companies. Welcome back to another episode of the DevSec for Scale podcast. With me today is Mike Malone, CEO and founder of Smallstep, a DevOps-focused automated certificate lifecycle management company. Mike, thanks so much for being on the show with me. And before we get to learn a little bit more about you and what Smallstep is doing, let's get right into it, and we'll talk about the topic of passwords and logins. What are the main methods developers are using today to log into various applications, and why have we made it so complex?
Yeah. Hi, Jeremy. Great to be here. The main methods everybody is using to log into anything, I'd say today, is some form of shared secret or symmetric key, a password, an API token, call it what you want to call it. But functionally, that's what people use for the most part to log in to anything. And most people don't think of that as complex. I think the reason that that method is, I'd say, overused in applications where maybe it shouldn't be, is because it seems simple, but it's deceptively complex. A password is somewhat intuitive. A secret phrase or something is easy for someone to understand. But when you try to productionize that technique, when you try to bring it to a large scale system, and you realize that there's a whole pipeline of infrastructure that needs to pass that secret around and needs to be shunted around across network, people might have eyes on it, and you need to govern and manage that secret through that whole life cycle. That is an incredibly complex thing to do, to the point where I think people ought to not be using that technique quite as often as they do.
Yeah, I guess that could also bring us to the question of what made developers come up with their applications and then decide to say, well, for my application, I would like you to log in this way versus that way. There must have been some thought process behind what was the easiest plus most secure all at the same time. And then we kind of got into this whole, I guess, just sort of complex, whatever you want to call it, ocean of various types of login procedures.
Right. Yeah. So how did it start?
That's an interesting idea.
Yeah, that's a good question. That's it's here now, right? Yeah. There's momentum behind it.
Yeah, I guess we can't really go back at this point. So,
yeah.
Let's keep going. Actually, let's learn a little bit more about you, Mike. Why don't you tell us about yourself, background, what you're doing at Smallstep?
Yeah. I mean, my background is I'm a nerd. I'm a software engineer, learned programming when I was in middle school, So I like to say I'm a distributed systems guy. I like to say distributed systems architecture is sort of my happy place. I like building large software systems and building teams that are building large software systems. And I have had the good fortune to be allowed to do that professionally, basically my entire career. And that's really how I got into doing Smallstep. I got running with the DevOps crowd and the microservices and cloud native cloud before all those terms were invented by marketers, I guess. So that's been my life, right? Is that space, modern software technologies, techniques, philosophies, agile, all that good stuff. And the impetus for Smallstep was really that an incompatibility between those technologies and techniques and the sort of status quo of cybersecurity. the inability to layer on security technologies into an operational environment that was using, CI/CD and automation and config management and containers and all that stuff. So that's how I got to where I am, high level.
Great. So yeah, I mean, well, why don't you also give us just a little bit more detail into what certificate automation is, how that works?
Yeah, totally. We're an open core open core company, which means our core technology is open source, and that core technology is a certificate management tool chain. So certificates, high level, really old technology, in fact, predate the web. But it's at its most basic form, a certificate is just a data structure that has a public key and a name in it, and it's signed over. And it's just saying like, hey, like Mike's public key is X, right? Primarily, we're issuing X509 and SSH certificates, although there's some more niche certificate types that we can manage as well. And those are mostly usable SSH certificates for SSH and X509 certificates for TLS, which is, the most widely deployed cryptographic protocol in the world, and it's used for pretty much everything. So it's a network security technology at the end of the day. It's identity and credential management for network security.
Well, yeah, we'll get into a little bit about the asymmetric cryptography as well. So what would be, in your eyes, the most ideal, secure, and non-invasive way that any user, even a non-technical user, would be able to use to log into any application?
Yeah, I mean, the way I like to think about it is like as any entity, like, a person or a device or anything has an identity, like in a singular identity typically. And I think the simplest thing you can do is to give that entity one way of authenticating that identity, one credential that it needs to worry about. For humans, single sign-on is probably the best technology that we have. So like the older protocol is SAML, the newer protocol for that is OAuth plus OpenID Connect or OIDC. For devices or virtual devices, it's harder, but it's becoming standardized. And I think the technology that's becoming ubiquitous are these cryptographic coprocessors, trusted platform modules, or TPMs. Different platforms call them different things. A generic name is a TPM. But some specialized piece of security hardware, cryptographic hardware that is bound to that device and really identifies that device. And this sounds obscure and complicated. And like anything, if you go deep, it is, but so is a microprocessor. But at a high level, it's pretty straightforward stuff. It's just some artifact that's sort of tied to this device or to this human, something that only you would know, Jeremy, can be used to authenticate you. I'd add to that, like, for humans, a big problem right now is phishing. And the solution to that is, the best solution that we have right now are security tokens, passkeys, as they're being called now, FIDO, WebAuthn, whatever standard is relevant to, the layer of the stack you're working in. And what underpins most of this stuff is asymmetric cryptography.
Yeah, so that's I guess the root of what we're dealing with, right? I mean, so when you're talking about asymmetric cryptography, let's talk a little bit about what that means from a little bit of a lower level. Our audience is pretty savvy with this kind of stuff. I'm sure they've heard of cryptography. They know at least, on a shallow level what it means. So can you give us a short primer on, what asymmetric cryptography is, and how that could be sort of a better solution, how you could implement it in a better way?
Yeah. I mean, well, let me start by saying I'm not a cryptographer. So, but you don't have to be to use to use this technology effectively. there are people who are smarter than me about the mathematics. I like to say, like asymmetric cryptography is a magical gift from mathematics to computer science, right? And what it enables, like unlike symmetric cryptography, where like if I was authenticating to you using symmetric cryptography, functionally both, like at least two people would need to know the secret, you and me, whether we're talking about a password or some sort of symmetric signing technique. At the end of the day, like both of us would have had to have eyes on the secret at some point. Whereas with asymmetric cryptography, you have a public and a private key. And I can sign something with the private key, and you can verify that signature. You can confirm that the signature was signed by a specific private key using the corresponding public key. So that gives you the ability, that gives me the ability to prove to you that I possess that private key without you ever seeing the private key. So I'm the only one who ever sees or has eyeballs on that. So, the math goes deep on how that works, but again, like there's an intuition there that's really powerful that doesn't require a deep understanding of the mathematics to leverage. And again, going back to these like coprocessors, things like security tokens or TPMs, that private key is generated on this coprocessor, like take the secure enclave for an iPhone or something like that, and can never be taken out of that secure enclave. So that it's bound in silicon to a specific device, and that secure enclave may be soldered onto a motherboard, right? You have physical characteristics that help you, with high confidence, as good as we can get, know that a specific piece of hardware was involved in an interaction.
And you could theoretically offer any user with any device, mobile, computer, whatever it is, a way to securely store that private key that they could use in order to authenticate with any application that they would have needed. I mean, hypothetically, I always kind of use like Gmail as like a generic, generic application for everyone, because everyone knows it is like, okay, well, it's email. So like you could have your iPhone open up your mail app, and instead of just going straight into the mail app or asking for a login and a password, it would say, I now know that inside your phone is that specific private key that's yours. It matches what we have inside of our machines, inside of our servers, and the public version, the public key of that, and says, okay, now you're now authorized to go into your email.
That's right. Yeah. So that would be like a use of this technology as a single factor, right? People talk a lot about multi-factor authentication, and like there's this universal second factor standardization effort around like, hey, let's use a password and some sort of bound private key. But I'd say for lower security resources, let's call them, you can use a hardware bound private key, say on a device where that you have good governance, right? Say a managed device, and that the hard drive's encrypted and password protection is turned on, and like the lock screen is turns on after 1 minute or something. So like, well, this is Mike's laptop. Mike's the only one who can get into the laptop, and we have a way of identifying this laptop. You can use that single factor, the identity of the laptop, as a stand-in for identifying Mike, and make a completely transparent but highly secure, unphishable authentication flow. So you can raise the security bar and raise the usability bar at the same time.
Yeah, the only thing I think about is actual implementation for average users, right? What does that require from them? What sort of configuration does a normal human who doesn't know how to use any of these types of authentication methods, how do they implement that?
Well, so are we talking about the end users who are doing the authentication, or are we talking about the engineers who have to implement the authentication techniques?
Well, let's assume that we've gotten past the implementation from the developers. Now let's talk about the end users actually, because at the end of the day, you're talking about, your mom and pop who, want to get into whatever applications they use on a daily basis. And they don't want to do more than, let's say, their fingerprint or username and password. They don't want this. What is this key thing I have to put where on my phone, and how do I get it on my computer? How do you do that?
Right. Well, I mean, if it's done right, the answer is potentially nothing. They don't even need to know that it's happening. It can just happen because this is authenticating the device, and the device knows how to authenticate itself. So implemented correctly, this can be completely transparent to the end user. It just works.
Oh, that's the dream, I guess. So what would be then the pitfalls of using asymmetric cryptography for humans, we'll call it?
Yeah. Well, there's a tooling gap and a knowledge gap. I'd say aside from those, I don't see major pitfalls. Asymmetric cryptography is harder to implement than symmetric shared key cryptography. So there is some implementation effort involved, but there are good libraries, well-maintained libraries in modern languages and modern stacks. Golang has a phenomenal crypto library. Maintained by Filippo Valsardo, and so there are great tool chains, and I'd say the biggest gap is tooling and understanding. The tooling gap is why Smallstep exists, right? Like our mission is to democratize this technology, make it more accessible to everybody. It doesn't need to be as baroque and specialized as OpenSSL makes it seem. Look, OpenSSL is a great library. I don't want to spread FUD or anything, but the flags and it's got a lot of historical baggage, and if that's your only exposure to this stuff, it doesn't have to be like that, right? And yeah, like I said earlier, you don't have to be a mathematician and understand the ins and outs of asymmetric cryptography in order to use it. If you want to go that deep, then great, more power to you, do it. But you can use it without that level of depth of understanding.
And I think what's cool about certificates, from at least my understanding, is that you have this many-to-one idea rather than sort of like one-to-one, which in essence is one-to-many, right? So not everybody needs to have their own private key, which relates or correlates to their own public key that's sitting on a server. You could just have one certificate that is authenticating thousands of private keys. Is that correct?
Yes, in the sense that you have a certificate authority, right? So you have that one private key that's being used to sign all of these certificates, as opposed to what some people call simple public key infrastructure, or SPKI, sometimes called spooky. Which is what SSH uses by default, for example. So by default, SSH uses a simple public key infrastructure, which basically means instead of using certificates, there's a file on disk on every SSH host that says, Mike's public key is X. So there's no certificate. I just have, as the end user, I just have a raw private key, and the server, every server that I want to access has my public key. Whereas with a certificate, every server has the certificate authority's public key. And when I log in, I present a certificate that has my public key, my name, and a signature. That signature comes from the certificate authority. So that certificate-based public key infrastructure, it's incredibly flexible and incredibly scalable, which is why it's used on the web, right? It is truly web scale. It is what Web PKI is built on, is this notion of certificate-based public key infrastructure. So it's highly scalable. It's peer-to-peer, large distributed solution for distributed systems.
So asymmetric cryptography, along with ensuring there's a certificate authority. Let's get a little bit more detail on this idea of a certificate authority, how it would work, who can be a certificate authority.
Sure. I mean, anyone can be a certificate authority. There is, I mean, a lot of people are most familiar with the web PKI, right? Like the way that, if you go to google.com, your browser is verifying Google's certificate, right? And that Google certificate was issued by a publicly trusted web PKI certificate authority. And when I say publicly trusted, what that actually means at the end of the day is there are a couple companies that have what are called root program management root management programs, I should say. So like Mozilla, Apple, Microsoft, and most recently Google started their own root program. And they ship with their browsers and operating systems a trust store, just a list of root certificates that are trusted by default. And so for a web PKI, you need to buy, or if you're using Let's Encrypt, which you should be using automated certificate management, that's a big pro tip, then you can get for free a publicly trusted certificate for your domain name. But that same technology can be used in many other scenarios for internal network security, zero trust network security, and you can run your own certificate authority. You don't need to, and in fact, for a lot of reasons, should not be relying on the public web PKI for those internal interactions. You should be managing a certificate authority of your own. So you absolutely can, and that's what Smallstep helps with. And I know Aculus has some offerings there as well.
Yeah, we do of course offer our own certificate authority, because if you trust us, then you trust our authority as a certificate authority. Hence, you can use us for your own work within the secrets management space there too. So yeah, that's really, really cool. I think that was a really awesome, beginner's understanding and high level understanding for all of us about how to use, asymmetric cryptography with understanding how logins work and how, we're working to try and sort of make it easier for everyone, especially developers, to kind of centralize and not have to deal with as many of these extra steps when they're trying to get all their work done on a regular basis. Don't have to worry about this key and that token and this certificate and this login. So that's really, really cool that we're really coming to this understanding of what it means to make things simpler and help developers get their work done. And the last thing that I wanted to ask, which I ask all my guests, is if you can give us one or two of your own Mike Malone tips for improving developer security without disrupting developer lifecycles.
Well, I mean, I feel like we've talked a lot about that already. But
aside from that,
at a high level, I think approach security like you do everything else in the the DevOps space, right? Automation, like question the status quo, question what you're doing, and blame-free postmortems and continuous improvement. Those same techniques and philosophies need to be applied to your SecOps as well. If you're going to raise the bar there. So, I mean, a big one, a huge one is just automation. What can you automate and sort of eliminate the toil and the human factor from the equation.
Fantastic. Mike, this was an awesome conversation. I really appreciate having you on the show, and look forward to seeing what Smallstep continues to do in the certificate automation space.
Thanks, Jeremy. Great to be here.
All right. Thanks for coming. And to everyone listening, stay secure.